Okay, awesome. So, welcome everyone, and welcome Potuz. Thank you so much for joining us today.
Thank you for having me.
Yeah, awesome. So, welcome everyone to the office hours number 8. Today we have another special guest for AMA. So we'll have a chat today with Potuz, core developer of Prism Consensus Client, and Potuz already have been a guest in the AMA before, but we wanted to have him back, especially because recently he's been working on EPBS, which is now being planned for Amsterdam. So congrats on that. It's been quite the ride, and I wanted you guys to meet Potuz to have a chance to actually talk to him and get some interesting opinions out of him. Hope you prepared some interesting questions. But before we open it for the audience, I wanted them to get to know you a bit, understand where you're coming from, what is your background. So if you can share about your journey, how did you get into Ethereum? Like, what have you been doing before? What brought you to the ecosystem?
All right. I am a researcher. I am a professor and mathematician. I have been doing math for the last probably 30 years now, probably less, 25 years. I've during the pandemics, I was like many colleagues and many probably of you. I was bored in a small apartment with a very young baby. My second daughter was born in 2020, and I really couldn't do any work at home. So I decided to look into crypto just out of boredom, I guess. I bought some Bitcoin at the time. I bought some Ethereum. I heard about Ethereum like moving to proof of stake. So I got very excited about that idea. I figured since my plan was to buy some crypto and get rich in 10 years and save it and never sell it for 10 years, I figured locking it into a contract without any withdrawals was a good idea to force me not to sell it. So I bought a validator worth of Ethereum, and I locked it into the contract as soon as the Beacon chain launched. And then I realized that I had put my money and that most of the developers were not 30 years old, that they had been working on this for not that many years, that there were a lot of bugs, that the whole withdrawal process wasn't even designed. And I decided, okay, I need to be more involved in this. I started submitting patches to Prism. Again, it was at the time where we were all living in a small apartment. I couldn't do any actual work in math at all. So I had a lot of extra time, and I started submitting patches to Prism. The Prism guys like started contacting me and even causing me some troubles with taxes because they started sending me money. And at some point, it turned out that they told me, well, you're going to continue doing what you're doing. We're going to start paying you and welcome to the team. And I didn't know what to do. They opened a lot of doors that I didn't know that they were open. They put me in secret channels that at the time were fantastic. I got a lot of information about bugs. I've learned about some bugs that were preventing the merge from even happening, some bugs in port choice, some bugs in the design of the Ethereum protocol itself. And I found those problems and trying to solve those problems and designing around those bugs an extremely fascinating topic. And that's how I got hooked. I went to Amsterdam as a guest from them at that time. And then I decided, okay, so I'm going to join the team and I'm going to start doing some more serious work. And since then, I haven't left my position. I'm still a professor. I still have my grad students, but I haven't done any serious research, and I should probably choose one or the other path because now it's unsustainable to do both.
Thank you so much, Potuz. Amazing. Thank you for sharing all of that. And it's very interesting, very inspiring. Get to see you're the most dedicated home staker that I've met who just starts fixing all the underlying protocol. And it also makes me realize that it haven't been so long since you've actually joined the core in a sense that the DEF Connect Amsterdam was like 3 years ago. And it feels
it was
like
2021, I think. Amsterdam.
2022 was
22 was Amsterdam. Yeah, so I joined 2021.
Okay. Yeah. Yeah. So you get very active very fast, and I'm wondering what have been some first things that you worked in. How did you get started with submitting issues, or what was the first sort of project that you worked on as a part of Prismatic Labs? Then, what sort of issues?
Well, so what I did was I wrote, and this was at the time that I was already. So the first few things that I sent to Prism were very trivial patches, mostly about login or mostly about the user experience as a staker. I wanted to have like tools to actually monitor the node, and I just added my own custom like things that I wanted to have measured, and Prism didn't expose. At the time, we didn't really have a beacon API that was stable or shared among different clients, so we were free to do whatever we wanted on what the node exposed. But soon I realized that there was a big problem. One of the biggest bottlenecks is on hashing, and the Bitcoin community has a way of hashing. They have a really good trick to make the hashing, the SHA-256, much faster, exploiting the fact that we're only hashing 64 bytes instead of like the arbitrary chunks. And the IBM guys at the same time have a very nice library to do hashing in parallel of things, which is exactly what we do with when we're hashing Merkle traits. So what I did is I focused for the first few months in writing my own assembly library for hashing. So when I joined the team in Prism, I spent a good chunk of my time validating that this hashing library, in this field, there's this saying that you shouldn't roll your own crypto. Well, but now essentially every consensus client uses my hashing library. And so I spent a good deal of time like validating it, and fuzzing it, proving that it was good, and integrating it in consensus clients. And after that, after Amsterdam, I focused mostly on ForChoice. I implemented completely from scratch the ForChoice at Prism, and I am the maintainer, you could say, of the ForChoice and Prism. So most of for anything that touches ForChoice typically goes through me.
Thank you so much, Potuz. Awesome. Yeah. So you've been working on this area, and I'm wondering what brought you to EPBS, or how the specifically EPBS was created, where it came from. How do you see the current design in the future? Maybe if we can talk about that a bit. Yeah. I'm curious about the origins and how it differs from what your ideas were before and how it evolved over time.
Yeah, so there are different things that matter to different people. In my case, what matters to me is decentralization and trustlessness. What drove me into Bitcoin originally and into blockchain in general is the fact that I could, with my own computer, validate the chain, and I didn't need to trust absolutely anyone. When we merged, when we were about to merge, uh, Justin Drake a year or two before, and Vitalik had some posts into how we could scale by having a proposer builder separation. And having proposer builder separation is something that goes beyond just scaling or beyond the history of the problem. Is that it is natural that the people that can build the better blocks are people that have transactions, that have information that most home operators would not have. So it was expected that even before the merge, people were sending bundles with transactions with MEV and to extract MEV to miners, and it was expected that this market would generate anyways, would be developed anyways after the merge. So correctly so, now today, every single validator, like over 99% of validators, do connect with relays, and they try to sell their rights to produce a block. So in a rational market, it was expected that most validators would try to sell their rights to build a block to someone else that is more specialized, that could build a better block. And the problem was that there was no such relay before the merge. The first relay that got announced was Flashbots, and Flashbots said At the time, we only had one relay, and Flash was officially publicly said that they were going to be censoring OFAC transactions. And this is something that didn't resonate with me and with many other developers. At the time, the discussion was whether or not we would even support MedBoost. And it is a tricky discussion. Within Prism, this was a strong disagreement. Me and Nishan, for example, we did not want to support MedBoost, and we didn't really care if no one would use Prism. Some other teams argued that they would support it because they didn't want to risk having nodes forking their own clients. And then once you have one or two clients that are going to support it, if you are the client that will not support MedBoost, you're going to lose all of your users. So I think this was something that heavily weighted on some of my teammates. And rightly so. People spent years building the client, and I was just new, and I was advocating to drop all of our users. But anyway, so this was something that was in the back of our head, the fact that we were enshrining, we were going to use a software that was closed source. The relay was going to be a trusted player in an otherwise trustless blockchain. And this is something that some of us always wanted to get rid of. Not get rid of in the sense of forcing that the relay is not there, but get rid of in the sense of, like, if you want to trust someone, it's fine. But if you want to do a trustless interaction with the builder, you have the option. And that's the origin of EPBS, is trying to make it trustless, trying to make the trusted relay as an intermediary an optional thing and not a forced thing on the users. In as much as running your own node is also optional. You can just get your data from Etherscan, or you can get your data from an RPC provider like Infura, or you can run your own node and get the data from your own node, and you don't need to trust your RPC provider. So it is the same situation that EPBS provides. If you are an operator and you can produce a block, but if you want to sell your rights to produce a block, you can do this now not now, but after EPBS ships, in a trustless manner. Now, the history of the problem is that no one really cares about this, or most people don't really care about this, or the trade-off is not good enough that it doesn't justify for most people. This removal of the trust assumption doesn't justify inclusion in mainnet, which is a reasonable argument, because every time that you change the protocol, you add a lot of risks, you cost people a lot of money. Just the fact that we are going to ship EPBS most probably is going to cost hundreds of thousands or even probably millions of dollars to stake in pools like Lido, for example. So you have to weight these things. And if you're going to make a change in the protocol, there are pros and there are cons, and you really need to weight them. Most people are against changing just because the removal of the trusted relay. Now, what happens is that EPBS, ironically, by separating the block from the payload, also allows the network to scale, and it allows the network to scale optimally. So we know that the best utilization of the slot would happen with the exact type of pipelining that EPBS provides. By separating the block from the payload, what the node gets is essentially most of the slot to execute the payload. Today, you get a block, and the consensus block has three things. It has a consensus block that you need to validate. It has inside the list of transactions, the execution payload, that you need to validate the execution. And it also comes with a bunch of blobs that are broadcast separate, but they have to come at the same time, a bunch of data, that's data for rollups in the form of blobs. And those blobs need to be checked that they exist. And all of this happens between second 2 and second 4 in the slot. So during those 2 seconds, you're doing 3 different things: validating consensus, validating execution, validating that the data exists. And at 4 seconds, you attest to the block, and then the chain advances. And from second 4 to second 12, the node doesn't do anything. So this is what is actually the bottleneck today into scaling Ethereum, besides other discussion of state float, and we can get into that if you want. But if I wanted to run Ethereum at, say, 100 million gas today, we couldn't, because we don't have enough time to execute the payload with 100 million gas. The payload could take more than 2 seconds, and we only have 2 seconds today, so we couldn't. So what EPBS does is it gives you about 8 to 10 seconds to execute the block, and about 8 to 10 seconds to transfer and broadcast the blob data. So that sort of scaling is what got most people hooked into shipping this, and that's why it got SFI'd for Glamstead.
Yeah, awesome. Very well. Yeah, congrats again to that. That's feels like also the whole governance process is sort of smoother, and I hope that it sustains this way. It's been quite a lot of time discussing this, and now it's finally happening. So that's great. And guys, I hope you have some questions ready. Please feel free to raise your hand. I um, I wanted to provide some intro and some context so all the people here know what we are talking about, who you are, and I hope you have some cool questions. Yeah, Shane, please go ahead.
Hey, Shane here. I'm helping Mark over at White House with EPPF. So I'm just curious about like what aspects of the spec are still a bit uncertain, such as like a dual deadline PTC, for example. Would you say that like the pending payment withdrawal flow is pretty set, or is that kind of up in the air? Yeah, just curious as I like implement consensus specs, what should I think is like, oh, maybe this a little bit later?
Yeah, so that's a fantastic question, and it's you're gonna get different answers depending who you ask that question. I mean, let me tell you the kind of things that are I think are agreed upon, and that no one would tell you this doesn't get in.
Hmm.
So these kind of things are the fact that we want the payload and the block to be broadcast separately.
Hmm.
We want the validation of the payload and the block to be completely separate. Let's not talk about blobs for a while. So that part of the validation part of the payload and the block, I think it's absolutely stable.
Yeah, I'm starting with that. Cool.
Sorry?
We're starting with that, so that makes
Yeah,
sense.
that's
Yeah.
so that part, how the payload is validated and how the block is validated is absolutely stable. I doubt there's not going to be any change on that. On the part of the communications, the engine between the consensus layer and the execution layer, I expect no changes there. Now, the dual PTC thing. So that's one of the areas that needs to be changed, that needs to be adjusted. There's discussion because of this free option problem that happens, that this is not an issue of EPBS, it's an issue of having this dual deadline. So for those of you that do not know about this, the way EPBS implements this separation is that we require that the payload with the transactions is available at a particular time in the slot. It should be there by, say, 4 seconds into the slot, or whatever time it is into the slot. Let's call that the payload deadline. And there's another deadline that is when the blob deadline, when the blobs should be available. And there's a third deadline, which is when the consensus block should be available. Today, those 3 deadlines are together at the same time at 4 seconds. But those deadlines are naturally want to be at different times. The consensus deadline wants to be as early in the slot as possible because the consensus block is useless. It's only there to tell us this is the head of a chain. The execution deadline is subtle because the later you put it, the larger the block that you can broadcast, but also the less time that you get to execute it. Because now execution comes from the deadline that it should be available up to the end of the slot. So that's the big gain of what's called delayed execution. And so that's some number that should be within the slot. Since execution takes a long time, that number cannot be too late into the slot because you need to execute the block. And in a later, in a ZK AVM world, that time is the time that it will take for a ZK prover to prove the block. So that time is a substantial amount of time. The blob deadline, on the other hand, wants to be as late as possible because all of the time that you get for that deadline is time that you are broadcasting and using bandwidth, which is a resource that we don't have enough. We don't have infinite bandwidth. So all of the time that you get on the slot to broadcast the blob is useful time for rollups. So that deadline needs to be as late as possible. And validation is trivial. You just check you have them or not. So it could be in principle really by the very, very last end of the slot. Now, the problem is that because there is these different deadlines, the payload is available, say, let's put a number, 4 seconds into the slot, and then you have 8 seconds to execute it, and the blobs are available 10 seconds into the slot. Then between 4 seconds and 10 seconds, the builder gets an option for free to invalidate its own block. The builder can monitor the markets, realize that he's losing money by including that block, and just take it out, mark it as invalid. This problem is called the free option problem. And the closer the two deadlines you put, the less of this problem we have. So what we need is to benchmark correctly, get good numbers as to what are the deadlines that we want. There's an inherent trade-off between scaling rollups on every single slot versus having some missing blocks by a builder that would be malicious and would just, or rational, and would just not, would invalidate its own block. So what we want is to have good benchmarks, and probably if this problem is just severe enough, just have the two deadlines together, for example, in which case the problem disappears. My intuition is that we're going to have some middle ground of what a number that would be considered reasonable enough to determine a good block count for rollups. Now, my intuition is that we're just anyways going to go with this dual PTC thing. And in the worst case scenario, just put the two constants to be equal. And that's it. And that's a way of not having dual PTC by having the dual PTC with the same deadlines. So that part, I think it's also stable. Now, some people want to, well, we're still getting like different versions of EPBS with or without a relay, with enforcing or not enforcing trusted payments and so forth. I need to unlock myself, sorry. So some people will still push, and we will see this push up to like the day that the fork is shipping to remove trustless payments. This is going to be something that people want to get out. And it's natural because it touches some people's money. EPBS, the way it's designed, will naturally shift money from certain parts of the markets to other parts of the market. The auction will naturally shift into being an open auction, into being a sealed price auction. There are a lot of people with commercial interests that are very much touched by this, so they're certainly going to be interested in removing this just from a purely financial perspective. There's also interest in removing trustless payments from a protocol perspective. It is complication. It is complexity that is added into the protocol. It is much less complexity than the separation itself, but it is complexity. It's a non-zero complexity that you add into the protocol. For example, Lido needs to pay to have new contracts to monitor the payment, that it will come instead of in a transaction, it would come now with a withdrawal. So it is a trade-off. And for some people, they like the trade-off, like myself, and some people don't like the trade-off. So if you ask me, I would say that this is something that is stable. We are going to ship it with trustless payments. Every single CL dev that I know wanted to have it with the trustless payment, except Dablion, which is the only one that officially said no. Among the CL devs that I know, I think he's the only one that actually officially pushed not to have. EF research, there's many of them that don't care or are actively against, and some people in the community are against. So I think we're gonna see a push to remove this, and it's unclear to me what's going to happen. As I said, one of my main motivation was removal of a trusted player. I would be very, very sad if this is decided to be taken out, especially because it's minimal complexity compared to the actual EIP. I hope I answered more or less your question.
Yeah, pretty much. And I just one point that you said was that like we're for sure separating payload from consensus block. Quick follow up is that for the local builder flow though, they're still going to be getting an EL payload from get new payload in the normal execution payload shape. Uh, and I'm curious when they are bidding for the block, will they just use the execution payload, grab the relevant fields, and put that as the new like execution payload header, then hold on to the other fields from execution payload until it's time to actually create, an envelope.
Correct.
And
Correct.
they wait till 40% of active stations or something, just like
No,
a
you don't
like
need to.
builder
You don't
would
need to
do.
count attestations at all. I wouldn't
Okay.
count attestations at all. There's no unbundling possible on EPBS. I don't think you need to count attestations. There is an unbundling possible if you slash yourself and you're also colluding with the next proposer. So if you have two blocks in a row and you slash yourself and you equivocate on the first block, you can unbundle the payload. But without this sort of shenanigans of having two blocks in a row, as soon as you broadcast your payload after the 4-second deadline, you cannot be unbundled. So it's useless to try to count attestations. So the workflow of how I would implement this, how this is implemented in Prism, is, as you said, you request a payload from the engine, the usual way we do when you're about to propose a beacon block. Out of that payload, what you do is you just cache the hash, cache the payload, and produce a header. Then you request a header or bits from the builders. If you choose to use your own, then you just include your own and you sign twice. You sign the header and you sign the block. You broadcast your block and immediately you broadcast your payload because you're not equivocating, so you don't care about having attestations. If you're using the builder, well, just put the header of the builder. So for self-building, there's no need to be doing with different deadlines or anything. Just broadcast everything together.
Okay, cool. Yeah, part I was still curious about. Thanks.
Thank you so much. Great discussion, guys. We have more questions coming. June.
Hi, Potuz. My name is Jun, and I'm working for SSC related things on Prism right now. So, and congrats about the recent news. So, I'm also a big fan of EPBS. So it was really amazing to be SFI'd recently. So, my question is about the core dev itself. So, I think shipping a new features as a core dev is important. Also, as well as maintaining the code base and improving the performance and the stability of the client is also important. So, what's your priority right now for this kind of viewpoints? So, and what's your team's priority for as a core dev?
So that's another great question. I'm not the right person to answer that question. But I can give you a personal perspective, but it's definitely not shared, nor I'm speaking for my team. But yes, as you said, there's this three different things: shipping new features, coding for the features that were already scheduled to be shipped. So one is designing the new feature, prototyping the new features that might never exist or might never be agreed upon. There's features that were already agreed that we're shipping for the next fork, and there's features that were already shipped that need to be maintained and need to be optimized and need to be analyzed for bugs. Now, there is a consensus among essentially most core devs and core devs in general, not only client devs, but researchers, community members, devs at the application layer and so forth. There's huge pressure to deliver forks more often, which means much less time to actually do the last one of the three items that you mentioned. And in fact, in Prism, we have known bugs, known bottlenecks that are actually affecting the quality of our code, not only the quality of our code, the actual performance of the node that we just don't have time to work on. because we are prioritizing, you might say correctly or incorrectly, I don't know, but we have some people that are already overworked working for the fork that was already arranged. We have some people like myself working for the fork that wasn't arranged or was sort of like SFI. The scope of Gladstone hasn't been decided yet, and people like myself are working on that fork, and essentially no one has time to work on the bugs that we know exist. So the performance issues that we know exist. And I think this is general for most clients. I think most clients have the situation in which it's very hard to find time to work on things that are maintenance. This eventually would be a problem. It's a problem that it's hard to solve. One solution, for example, is lean type of Ethereum, where you just start from scratch a new client, and that's it. Just replace a team, replace a full code, and that's it. So that's one way of maintaining code. Just start from scratch and have new code. Another way would be to not ship forks so often and have time to actually maintain your code. Another way would be to increase the number of people within teams, but that's very hard. We are lucky at Prism that our mother company not only does allow us to do whatever we want for L1, they're not influencing our decisions on L1, but they're also like financing as well. So we have a large team. But other teams like Nimbus, they are very few of them, and they need hands. They need to code. If we schedule a very large fork, they would definitely not have time to work on nothing else. So yes, I think it's hard to balance these three things that you mentioned, and it's also controversial. And there are some pushbacks. The fact that we are working on prototyping things like EPBS got some researchers mad about the fact that we're also delaying Fusaka. So there is contention about these three things and how much should we allocate on these three things. Different people believe that these three things should be allocated in a different way, or that certain aspects should be done by certain people and some other aspects should be done by other people. Pipelining this is very complicated in a decentralized way, in a decentralized environment. It's much simpler if we were just a company. If we're just a company in a pyramidal situation, I would just say, you work on this, you work on that, and you work on that, and that's it. If we had an Ethereum project manager, we could just immediately allocate resources optimally. But that's incompatible with having a rough consensus type governance system.
Yeah, thank you. So if I remember correctly, Prism has known issues and progress about improving performance, like state diff, or that you are working quite a while. And also I remember about someone saying that every core dev has to be allocated for the next fork work. So I would say M+2 fork every day. So I think it's quite a dilemma for not only for this client development, but also the worldwide products. Yeah, so I think it's a dilemma. Yeah, thank you for your answering my question.
Very well, thank you. Dimitris, question next. Yeah.
Yes, sorry, maybe I'm a little bit out of topic, but I was interested in your background. What kind of math did you do over the last so many years? And during the transition, you said that you had some time because of the coronavirus and your family situation, but did you have any prior coding experience? I mean, how did you feel about it working with developers where, like, I don't know if you were doing pure math, but for example, in mathematical physics, there was not very much coding apart from Python. And also, do you miss doing research? And do you think that your background was useful to do research on Ethereum, like on the classical sense, like publishing papers, presenting in conferences and all that? And I mean, based on your last answer, I mean, couldn't we do math to optimize the way that people are allocated in a decentralized way on how they spend their time in these kind of tasks?
Okay, so these are 4 different questions I counted. I'm not sure if I'll miss some. Let me go through them in a while. So first of all, what type of mathematics did I do? It's very, very pure. I work on algebraic geometry and representations of infinite dimensional algebras. It is something that has connections with conformal field. Most of what I do comes from connections with conformal field theory or string theory. Yes, it was as pure as it could get. Not any applications at all. Coding experience. I am perhaps from a different generation, or I am what you would call a nerd, I guess. My hobby when I was 12, 13 years old was to disassemble viruses. I had my own collection of floppy disks with like each one of them infected by whatever virus was on the boot sector at the time. And yeah, so my dream at that time was to write a good virus that would just write itself into the CMOS of computers so that not even wiping the disk or the hard drive would erase them. So I would say that I just grew up coding as a very young person. So since I have memory, I've always coded and I liked. Incidentally or ironically, I always disliked and I still dislike Golang, and I work for the team whose client is in Go, which is something that causes me personal trouble. I am mostly a C++ programmer. Again, my library is in assembly, so that's what I feel more I would say at home. Perhaps Rust is something that I might like, although I still view this as a language that people don't know how to correctly write in C use. Anyways, I digress. Yes, I think I've coded a good chunk of my life, and like many people that coded for a long time but didn't work in this environment, the big difference between coding and coding professionally is working in groups. It's not coding something efficiently or having a good algorithm that is done efficiently or in the best possible way. The most important thing about working in groups is have your code being read by others. It should be readable by other people. It should be maintained by other people. It should not induce other people to write bugs. And if you're reviewing other codes, you should be able to read their code. You should be able not to add bugs because you didn't understand their code. So working in teams, I think, is a huge difference from what I was used for my entire life about coding. As you said, Python is a very common language, both in mathematical physics and in pure mathematics. Sage is a huge library that has a lot of collaborators from a lot of people, that include myself. And yes, we typically do work in Python, but I think most mathematicians that I know would know how to write Fortran or C and C++, because those are languages that we used from a very young age. Now, the other questions you asked. One was about using math to allocate correctly people. The problem is not about the resource allocation in an optimal or non-optimal way. We do know that we are not optimal. This is just a matter of fact by the fact that we need to have 5 different clients, and then these 5 different set of people have different interests. Each one of us want to have a different feature, or each one of us have a different view of what Ethereum should be from now in 10 years from now. So it's not a problem of how do we get there, or even where do we get. The problem is we just don't agree. And having the fact that we want to have this decentralization and we want to have governance being decentralized, because in a blockchain that is not ossified, the only thing that determines the security is its governance system. So this is an important concept that people just tend to not get. Ethereum is strong. It is as strong as its governance system is. We do not want to be centralized in our governance because even though it would make us much more effective, it would be easy to take. It would be a fatal flaw for Ethereum to have a centralized governance system. And having an algorithm in particular, or even the concept of an algorithm, I understand that you're not suggesting that we're just programming and then we're just dividing people to whatever it is. But the thing is that having some sort of centralized form of allocating resources into which problems should be solved, I think it's a mistake. It's something that we do not want. We want to have disagreements. We want to have difference of opinions, and we want to come to agreement, even though we might let some people not satisfied with the decisions. And this is what happens. And this is what has been happening for a while in Ethereum. And it would be very sad if we lose this system that we have today.
Yeah, thank you. I was also working with Sage, so I was in algebraic geometry. I was doing intersection theory in the model space. So yeah, sorry. Thanks.
Thank you so much. It was a real nice answer. Pella has another question. We still have time. Go ahead.
Thanks, Mario. My question was regarding PTC, inclusionless committees, and all these committees we keep adding. Do you think we're adding too many committees? And do you think that will cause any problems down the line, or if we'll need to consolidate them or something like that? I'm not sure if there are any issues with that. It just doesn't seem super elegant. So I was wondering your thoughts on that.
I completely agree. I don't know how to answer that question. And we all get the same feeling. Protocol, the EPBS, the EIP is not elegant, to put it nicely. It's horrible. It's a horrible monster. Combined with Fossil, it becomes even worse. I agree. This is not an elegant protocol. It's also not an easy problem to solve. So, and the fact that it took us many years to get where we are, and we do not know, we don't have another solution, is what makes us like put these proposals forward. Is the fact that we know they are horrible, and we still think they're worth the change. Now, regarding your actual question, which is how do we deal with all of these committees? In fact, what we hope for Ethereum in the future is, I don't know if you're familiar, for example, with this rainbow staking kind of ideas that Barnabé and Ray were posing a couple of years back. But the idea would be to have different type of node operators. Today, we do have different type of node operators. We have the operator that can actually build their own block, and we have operators that can't even build their own block, and they need to outsource it. We have operators that don't validate, but essentially every node operator today needs to be able to at least build an empty block, and needs to attest, and needs to sign sync committee messages and so forth. We envision a future, the long time future of Ethereum would be a future in which we have operators that are running on asynchronous devices, say a cell phone that turns on, does something, and then it turns off. We have operators that run on very low powered energy devices. We have operators that run on home computer and so forth. We want to have a very large number of includers. We want to have a pool of includers. We want to have a very large pool of attesters. And we don't need such a large pool of proposers, or even less for builders and so forth. So my guess is that since these committees that we're adding, they represent different needs to run them, my guess is that we are going to keep them, and we might even add more as new attributions for validators or attributions for full nodes appear. I expect that we're going to have different set of committees, because they will naturally live on different hardware that would run them. One good example is inclusion lists. If we are in a world in which most node operators don't even have the state and not even have a part of the state, then those operators will not be able to submit transactions to be forced included because they don't even know if a transaction could be included. So in a future where we are in a ZK world, we need to be very careful as to where do we get these committees of people that are going to ensure that we are censor resistant. Yeah, so I'm sorry that I'm answering your question without answering your question, but my suspicion is that once we are in such a world in which different hardware are determining different type of operators that you run, I expect that these committees will get even more separated and the protocol would get uglier in that sense. Even though, I mean, if you ask this same question to Justin, he's going to tell you that it's going to be more beautiful and it's going to be tied up, everything in a nice package. So there are different opinions about this.
Yeah, it makes a lot of sense. Thanks for the answer.
Okay, thank you. And Lee has a question.
Yeah, I'm actually was reading your post, Ethereum research about the faster blob propagation in Ethereum. Also, actually, I met Mary at ECC this year. She gave several talk about the optimal P2P and using random linear network. But I also say you already mentioned that actually, because of the coefficient and the field, to have a like efficient small field coefficient is hard. I'm wondering actually if we use let's say the random linear network coding. Uh, uh, I mean, from my understanding, the proof cost and the verification cost, because it involves like the multiplication MSM for the proof, right? So would be pretty high, right? So, but I don't know, like I don't know the accurate number or the performance. Would that be high? Would that be hard, or is that okay actually?
That's a very good question. I assume that most people here don't really know about that work. So let me just quickly describe what you're talking about. The idea is one of the bottlenecks we have today on Ethereum, and that we kind of are solving in a way for blobs, is to propagate blobs, is we do erasure coding. To propagate blobs, to propagate the data, we do something that is called Reed-Solomon encoding. We make larger the total amount of data that needs to be propagated. We artificially enlarge it. So we have, suppose 8 blobs, we make it 16, we might make it 32 in the future. But then in such a way that anyone that actually gets 8 can recover the whole data. So this allows us to propagate in a much more efficient way the blocks. Now, such a system is not there yet for blocks. And this is something that erasure coding for broadcasting or for multicasting is something that has been used in television system or in radio system, has been, or the internet in general, has been used in the last 40, 50 years. Probably not for the internet, but certainly for television. And so what I did is I just grabbed very old literature. In particular, this random linear network coding is work from professor at MIT, Muriel Medach, and her students, and actually comes from even earlier, but has over 15 years. And I just wrote down what it would be, what are the parts of that, what are the changes that would be necessary to include this in Ethereum. So the idea would be to spread the block, the payload, and the block, the consensus block, chunk it in many, many chunks. We're talking 10, 40, 100. It depends on the sort of like topology of the network. And then broadcast these chunks separately. And each node, instead of like rebroadcasting the same chunk that they received, they would just mix them randomly and send this random linear combination of these chunks to new peers. The idea here is that you never receive the same message twice. So every message that you receive is useful. So if, say, there are 100 chunks, as soon as you get 100 messages, it doesn't matter from whom, from where, it doesn't need to be a particular chunk, you will be able to recover the full node, the full block. Now, the question in particular was about the cost of computing this. There's a matrix that you need to compute. There's a matrix that you need to invert, and this matrix has values in what is in mathematics known as a field. Now, for the purposes of security and randomness, we only need this field to be very small. So we need, say, to choose numbers between 0 and 255. And that's more than enough from what we need. On the other hand, we need to make sure that the original block was sent by the proposer and that no malicious operator in the middle can inject crap. That's the big problem when you're dealing P2P network in a decentralized and permissionless environment, that anyone that hooks into the network that says, I am a validator, can just claim, I am the proposer and I'm sending you this block. How do we distinguish this? So today we have a signature. The proposer signs the block and we perform a BLS check, a BLS signature check on any message that we get. So if someone makes a block appearing to be the proposer, it will need to forge that signature. And the point is that what we need in an ideal world is that sending that message, the cost of preparing and sending that message should be larger than the cost for us to verify the signature. As long as that happens, then it's not profitable to try to flood the network with garbage. So that's why we want to keep the costs as small as possible to verify these chunks. However, verifying a signature per chunk would be horribly bad. If we have 100 chunks, there's a difference between verifying one signature per block to verifying 100 of them. That's going to be very costly. So we have devised a way in which there's still only one signature, but there are many commitments using some elliptic curve, and then those commitments need to be verified. Now, the actual answer to your question is no. If we're talking about 10 to 40 chunks, the verification of the commitments and the arithmetics on this large prime are not a problem. They're very, very fast. Pedersen commitments on the Ristretto curve are of the order of microseconds. So I'm sorry, I'm locking myself because I forget to remove the screensaver. So that's not a problem. The problem with the large field has to do with the size of the scalar itself. For an elliptic curve to be safe, in the sense that no one can forge being a chunk from the proposer, you need 32 bytes per scalar. And that means that you're broadcasting 32 bytes per chunk that are extra. And this is garbage that we need to send that is not useful part, and we need to send on each one of the chunks. If we're talking about 10 to 40 chunks, that's not a problem. And that's why I believe that we are going to use random linear network coding, or some version of it, or some version of erasure coding. We are going to use in Ethereum Net 1 to broadcast payloads. This is something that we all agree, and I'm happy to work on something that is not contentious. This is not going to have an argument. No one is going to be against. We are going to ship some way of erasure coding for broadcasting the payload. But the biggest problem on this random linear network coding today for us in the design phase is to use it for blobs. Because when we go to blobs and we have hundreds of blobs and we want to send them all, then now the number of coefficients that we need is very large. And if we use 32 bytes per coefficient, that's just too large. And we do not have a way, we do not know how to make those coefficients smaller in a safe way. That's an open problem for design that requires someone that knows mathematics, and it's mostly, I would say, cryptography. And yes, it's still an open problem. There are some ideas floating around, but nothing satisfying.
Yeah, thanks. And I don't know if I have time, but I can send you the message later. Yeah, thanks.
Thank you so much. Right. Yeah, you stopped right there because it's the full hour, so we are out of time here. So thank you so much, everybody. I wanted to thank you again, Potuz, for taking your time. It was very interesting. I believe we learned a lot. We get inspired. Any last words? Any last advice you have for the fellows here? Something to finish it off with?
Sorry, I'm not good at those. But thank you for having
Okay,
me.
fair enough. Yeah, okay. Thank you so much, Potuz. Sorry for putting you on the spot there. Yeah. So thank you so much, everyone. It was great, and I'll see you on Monday again. And we'll have a recording of this coming out soon. Thanks again, Potuz.
See you guys.
See you,
Thank
everyone.
you.
Bye bye.
Bye bye.